Hi everyone. As you know, probably, I recently published this book, IS-2 Development, Design, and Production of Stalin's Warhammer. And one of the most prominent features of the IS-2 tank was, of course, its 122mm gun. This is a very powerful gun, but every so often I run into a claim that, well, it actually wasn't that powerful, because when engaging the Panther tank, sure, it could penetrate the front armor, the upper front hull at 2,000 meters, but if you slope the tank by 30 degrees, it can only penetrate at 100 meters. And, okay, an interesting claim. Decided to talk about it in some detail in this video. Another thing is that somebody in my YouTube comments said that, well, I'm not using my engineering degree enough, so this one's going to have some math in it. So let's talk about that claim. If you actually run it through the equations, it checks out. So the IS-2's 122mm gun, its penetration, according to Soviet calculations, at 100 meters is 165 millimeters of armor. Panther's upper front plate, 80 millimeters at 55 degrees. Line of sight thickness, that's 140 millimeters. If you turn it at another 30 degrees, well, line of sight thickness is now 161 millimeters, so yeah, more or less. So yeah, you can say that, according to math, the IS-2 could only penetrate the front of the Panther at 100 meters. Okay, interesting. Fortunately, geometry is a cruel mistress. So see our Panther tank here, and we turn it at 30 degrees. You turn this part at 30 degrees, but you also turn this part at 30 degrees. And the side of the Panther is actually quite thin, so this upper part is 40 millimeters at a slope of 40 degrees. The one behind the wheels is same thickness, but this one's sloped, so slope 40 degrees makes for an effective line of sight thickness at 50 degrees, or sorry, 50 millimeters. And then, of course, if you turn it at 60 degrees to the enemy, that's twice as thick effectively, so 100 millimeters of thickness. Unfortunately for the Panther, the IS-2's gun can penetrate 100 millimeters of armor at pretty much any range, I think at like 3,000 or 2,500 meters. So in an attempt to protect the front of your tank, you've actually exposed the side, which makes it a lot more vulnerable. And of course, if you're engaging the enemy like that, your gun mantlet is also about 100 millimeters thick, so there's actually quite a lot of the tank that's still very vulnerable to your opponent's gun. Doesn't quite really work out for the Panther crew. But the other interesting thing is that this side up here, effective thickness of 100 millimeters, well, there's trials, and I have to scan on my blog, where the T-34's 76mm gun penetrates the Panther's armor from this angle at a range of 600 meters. Now, obviously, the T-34's 76mm gun, the F-34, can't penetrate 100 millimeters of armor straight on, so, well, why does this happen? The answer is that line of sight thickness doesn't really tell you the whole story. If you go back to the front of the Panther here, like I said, 80 millimeters at 55 degrees gives you an effective thickness of about 140 millimeters. According to Soviet penetration tables, the IS-2 penetrates, the IS-2's gun penetrates 130-something millimeters at 1,500 meters. So the actual penetration distance for the Panther's upper front plate should be at about, less than 1,500 meters. And yet practical penetration trials show that this part of the armor could be penetrated at over 2,000 meters. So, well, what's going on here? Why is the Panther's armor so much weaker than calculated? Well, the answer to that is quite complicated. I'm not going to get into mechanics of penetration. There's a great YouTube channel that posts actual simulations of various materials and various shots being fired at them. You can go check it out. I'll put a link in the description. But I'm going to attempt to give you a very simple and summarized explanation. So, in simple terms, all of these penetration equations model a very simple scenario. Have the armor vertical, shell hits it, either it goes through or it doesn't. And that's it. So, normally, like I said, it's a bit more complicated. So the armor is presented at a slope, and you would think that, well, that's the line of sight thickness. There it is. That's how much armor the shell has to pass through. Not entirely correct. So again, penetration mechanics are quite complicated, but essentially what happens is force is a vector quantity. So if the shell hits the armor, the force the shell imparts on the armor is split up into two. One is the vector that goes perpendicular to the plate. One is the vector that goes parallel to the plate. And the force that's pushing against the plate is being balanced by what's called the normal force. And then the force that's pushing parallel to the plate isn't being balanced by anything. So in ideal conditions, if you have a completely rigid penetrator and a completely rigid piece of armor, shell hits it, this is equilibrium, this is not equilibrium, so bounces off. That's what a ricochet is. But since we don't live in a perfect world and ideal conditions like that don't exist, the shell hits the armor, and even if it ricochets, in that split second that the two are interacting together, energy is being transferred from the shell into the plate. And of course, the plate's normal force is acting on the shell itself, and either one or both of them are going to be damaged as a result. Now, mechanics of deformable solids is a whole separate course and very difficult one. But in short, these are more or less independent processes. So a shell can hit the armor, bounce off, but then the armor can take enough damage that it is destroyed. It is penetrated. There's a big hole through it. Chunks of metal are flying at the crew. And, you can argue, for example, Soviet standards say, well, penetration only counts if the shell is behind the plate, but when chunks of what used to be your upper front plate are flying in your face, it's kind of hard to argue that your tank wasn't penetrated. So why is this important? Why does this matter? Well, according to studies by British and American metallurgists, German armor was quite brittle, quite prone to being overmatched, and as a result performed quite badly when sloped. When compared to, say, British or American plate. So if you have this kind of scenario going on, like the front of the Panther tank, the shell hits it, it might actually ricochet or bounce off, but the actual armor is brittle enough that it's broken into pieces, and the pieces are flying into the tank. And, this doesn't count as a Soviet penetration, but the British, for example, their criteria was that the light can pass through the hole in the armor, so therefore that would count as a penetration. So yeah, in conclusion, math is great, but if you just take numbers and plug them into an equation and try to analyze the result without knowing what the numbers mean, you're rarely going to arrive at a correct result.